Imagine staring into the vast, endless expanse of the universe, only to hear a faint, inexplicable signal echoing from the depths of space. What if that signal wasn't just random cosmic noise, but a deliberate attempt to communicate with us? For decades, mysterious messages from deep space have baffled scientists, sparking debates, theories, and even dreams of contact with civilizations beyond our own. These signals, some fleeting, others repeating, have left us questioning whether we are truly alone in the cosmos. From the infamous wow signal to the enigmatic fast radio bursts, each message carries with it a story of intrigue and possibility. What do these signals mean? Are they natural phenomena, or could they be the first whispers of extraterrestrial intelligence? In this video, we'll explore 25 of the most mysterious messages ever detected from deep space, unraveling their secrets and uncovering the tantalizing possibility that we are not alone. Stay with us, because by the end of this journey, you might just find yourself looking at the stars a little differently. Now, let's turn our attention to one of the most iconic and puzzling signals ever detected, the wow signal. This mysterious radio burst, captured on August 15, 1977, has become a cornerstone in the search for extraterrestrial intelligence. It all began at the Big Ear radio telescope in Ohio, where astronomer Jerry Amon was scanning the skies for signs of unusual activity. What he found that night would go down in history. The signal, lasting just 72 seconds, was so strong and unusual that Amon circled it on the printout and wrote, "Wow," next to it, a name that has stuck ever since. The wow signal came from the direction of the constellation Sagittarius, and its frequency matched the hydrogen line, a wavelength scientists believe could be used for interstellar communication. But here's the twist: despite numerous attempts to detect it again, the signal has never been heard since. This one-time event has fueled endless speculation. Could it have been a natural phenomenon, like a comet or a distant star emitting a burst of energy? Or was it something far more extraordinary, a deliberate attempt at communication from an advanced civilization? Some scientists argue that the signal's narrow frequency range and intensity suggest an artificial origin, while others point to the lack of repetition as evidence of a natural cause. The truth is, we may never know for sure, but what makes the wow signal so captivating is not just its mystery, but the hope it represents. A fleeting moment that reminds us of the vast, unexplored possibilities waiting in the cosmos. And as we continue to search for answers, the wow signal remains a beacon, urging us to keep listening, keep wondering, and keep looking up. The wow signal didn't just capture the imagination of astronomers, it sparked a revolution in the search for extraterrestrial intelligence. Its discovery became a turning point, inspiring scientists to double down on efforts to listen for signals from the cosmos. This single, fleeting burst of radio waves demonstrated that the universe might hold more surprises than we ever imagined, and it gave the search for extraterrestrial life a renewed sense of urgency. In the years following the wow signal, the search for extraterrestrial intelligence, or SETI, expanded dramatically. New projects were launched, and advanced technologies were developed to scan the skies for similar signals. The idea that we might not be alone in the universe became a driving force behind these efforts, but the wow signal also highlighted the immense challenges of this search. Detecting a signal that lasts just 72 seconds with no repetition is like trying to find a needle in a cosmic haystack. The vastness of space, combined with the limitations of our technology, makes it incredibly difficult to pinpoint and verify potential alien messages. Despite these challenges, scientists haven't given up. In fact, the wow signal has motivated some of the most ambitious SETI projects to date. For example, the Breakthrough Listen initiative, one of the largest and most comprehensive searches for extraterrestrial signals, has dedicated significant resources to scanning the same region of the sky where the wow signal originated. Using state-of-the-art telescopes and powerful data analysis tools, researchers hope to catch a repeat of the signal, or perhaps something even more extraordinary. But so far, no luck. The WOW signal remains a one-of-a-kind event, a tantalizing mystery that refuses to be solved. This lack of repetition has led some to question whether the signal was truly artificial. Could it have been a rare natural phenomenon, like a burst of energy from a distant star or a passing comet? While these explanations are possible, they don't fully account for the signal's unique characteristics. Its narrow frequency range and intensity still make it a strong candidate for being something more deliberate. Yet, without a repeat detection, the debate continues. The legacy of the WOW signal lies not just in the questions it raises, but in the hope it inspires. It reminds us that the universe is full of mysteries waiting to be uncovered. Every time we point our telescopes at the stars, we're not just searching for answers, we're reaching out, hoping to connect with something beyond ourselves. And while the WOW signal remains elusive, it serves as a powerful reminder that the search is far from over. The next great discovery could be just one signal away. Moving from the tantalizing mystery of the WOW signal, we now turn our attention to another enigmatic cosmic event, the lorimer burst. Discovered in 2007, this brief but incredibly powerful signal marked the first detection of what we now call fast radio bursts, or FRB. Lasting just a few milliseconds, the lorimer burst was so intense that it released as much energy in that fleeting moment as the sun does in nearly 100 years. Its discovery was a game-changer, opening up a whole new frontier in the study of mysterious signals from deep space. What makes the lorimer burst so fascinating is not just its sheer power, but also its elusive nature. Unlike the WOW signal, which came from a specific region of the sky, the lorimer burst's origin remains shrouded in mystery. Scientists have struggled to pinpoint exactly where it came from, and this uncertainty has fueled a wide range of theories. Some suggest it could be the result of cataclysmic events, like the collision of neutron stars or the explosive death of a massive star. Others have even speculated that it might be linked to advanced extraterrestrial technology, though this remains a highly controversial idea. The challenge of tracing the lorimer burst source lies in its brevity. Fast radio bursts are incredibly short-lived, making it nearly impossible to observe them in real time or to gather enough data to determine their exact location. Adding to the complexity, these bursts often come from billions of light-years away, meaning they've traveled across vast stretches of the universe before reaching us. By the time we detect them, the event that caused them may have long since faded into cosmic history. Despite these obstacles, the discovery of the lorimer burst has sparked a surge of interest in fast radio bursts. Since its detection, dozens of similar signals have been found, each adding a new piece to the puzzle. Yet, the lorimer burst remains one of the most significant, not just because it was the first, but because it highlighted the potential for entirely new phenomena lurking in the depths of space. Its detection reminded us that the universe is still full of surprises, and that even the briefest signals can hold the key to unlocking some of its greatest mysteries. As we continue to explore the cosmos, the lorimer burst stands as a testament to the power of curiosity and the relentless pursuit of knowledge. It challenges us to look deeper, to ask bigger questions, and to remain open to the possibility that the universe might be far stranger and far more wondrous than we ever imagined. Now, let's dive deeper into the mystery of fast radio bursts, or FRB, and why they continue to baffle scientists around the world. These bursts are detected using some of the most advanced radio telescopes on Earth, which scan the skies for sudden, intense blasts of radio waves. When an FRB is detected, it's often a race against time to gather as much data as possible before the signal vanishes. The challenge lies in their unpredictability. Most FRBs are one-off events lasting just milliseconds, and they can come from any direction in the sky. This makes them incredibly difficult to study, let alone understand. What makes FRBs even more puzzling is their sheer power. Some of these bursts release more energy in a fraction of a second than our Sun does in decades. Yet, despite their intensity, their origins remain a mystery. Over the years, scientists have detected dozens of FRBs, each with its own unique characteristics. Some, like the famous FRB 121102, are repeaters, meaning they send out multiple bursts over time. Others, like the lorimer burst, are singular events never to be heard from again. This variety has led to a wide range of theories about what could be causing them. One leading idea is that FRBs are the result of extreme cosmic events, such as the collision of neutron stars or the explosive deaths of massive stars known as supernova. These cataclysmic events could produce the immense energy needed to create such powerful bursts. Another possibility is that they originate from highly magnetized neutron stars called magnetars, which are known to produce intense bursts of radiation. However, not all FRBs fit neatly into these explanations, leaving room for more speculative ideas. This is where the debate about alien technology comes in. Some researchers have suggested that FRBs could be evidence of advanced extraterrestrial civilizations. For example, they might be signals from interstellar spacecraft or even attempts at communication across vast distances. While this idea is intriguing, it's important to note that there's no concrete evidence to support it. Most scientists lean toward natural explanations, but the possibility of alien involvement keeps the conversation alive and adds an extra layer of intrigue to the study of FRBs. The ongoing search for answers has led to some fascinating discoveries. For instance, in 2020, scientists detected an FRB originating from within our own galaxy for the first time. This breakthrough provided valuable clues about the nature of these bursts, but it also raised new questions. Why do some FRBs repeat while others don't? What causes the variations in their brightness and duration? And perhaps most importantly, what can they tell us about the universe we live in? As we continue to unravel the mystery of fast radio bursts, one thing is clear: they are a reminder of how much we still have to learn about the cosmos. Each new detection brings us closer to understanding these enigmatic signals, but it also reminds us that the universe is full of surprises. Whether they are the result of natural phenomena or something more extraordinary, FRBs challenge us to think bigger and explore deeper, pushing the boundaries of what we know about the vast, mysterious expanse of space. Now, shifting our focus from mysterious signals detected from deep space, let's explore a message that originated right here on Earth. The Arecibo message, sent in 1974, stands as one of humanity's first deliberate attempts to communicate with potential extraterrestrial civilizations. This groundbreaking signal was transmitted from the Arecibo Observatory in Puerto Rico, using one of the most powerful radio telescopes of its time. Unlike the enigmatic signals we've discussed so far, the Arecibo message was carefully crafted by scientists, designed to convey basic information about humanity and our place in the universe. The message itself was a binary-coded transmission, consisting of 1,679 bits of data arranged in a grid. When decoded, it revealed a series of symbols representing fundamental aspects of human life and knowledge. These included the numbers 1 through 10, the atomic numbers of key elements like hydrogen and carbon, the structure of DNA, a depiction of a human figure, and a diagram of our solar system, highlighting Earth as the source of the message. The transmission was aimed at a star cluster known as Messier 13, located approximately 25,000 light-years away. This cluster was chosen because of its density, increasing the chances that the message might reach an intelligent civilization if one existed there. However, sending such a message into the cosmos is not without its challenges. The vast distances between stars mean that even at the speed of light, the Arecibo message would take 25,000 years to reach Messier 13. If a reply were ever sent, it would take another 25,000 years to return to Earth. This timescale makes the likelihood of receiving a response within our lifetime virtually non-existent. Additionally, the message's content, while carefully designed, is highly abstract. Without a shared frame of reference, it's unclear whether an extraterrestrial civilization will be able to interpret it correctly. The Arecibo message also raises important questions about the ethics and risks of sending signals into space. While it was a bold and optimistic gesture, some scientists have cautioned against broadcasting our presence to the universe. The potential consequences of contacting an advanced civilization, whether benevolent or hostile, remain a topic of debate. Despite these concerns, the Arecibo message remains a symbol of humanity's curiosity and desire to connect with the unknown. As we reflect on this historic attempt at interstellar communication, it's worth considering what such messages might mean for the future of our species. Could they one day lead to a profound exchange of knowledge, or will they simply drift through the cosmos unanswered? The Arecibo message reminds us that while the universe is vast and mysterious, our efforts to reach out into the void are a testament to our enduring spirit of exploration. And with that, let's turn our attention to another fascinating signal that has captivated scientists and dreamers alike. Now, as we delve deeper into the implications of the Arecibo message, we encounter a fascinating debate that goes beyond the science of interstellar communication. The act of sending such a message into the cosmos raises profound ethical and philosophical questions. Should humanity actively broadcast its presence to the universe, or is it wiser to remain silent? This question has divided scientists, philosophers, and even the general public, sparking discussions about the potential risks and rewards of reaching out to extraterrestrial civilizations. On one hand, the Arecibo message represents a bold expression of curiosity and optimism. It embodies humanity's desire to connect with other intelligent beings, to share knowledge, and to explore the possibility of a cosmic community. Proponents of such efforts argue that the benefits could be immense. Imagine the exchange of advanced technologies, the sharing of scientific discoveries, or even the opportunity to learn from a civilization far older and wiser than our own. These possibilities inspire hope and excitement, fueling the belief that reaching out is a natural extension of our exploratory spirit. However, not everyone shares this optimistic view. Critics of interstellar messaging warn of the potential dangers. What if the civilization we contact is not benevolent? History on Earth has shown that encounters between advanced and less advanced societies often lead to exploitation or conflict. Some scientists, including renowned figures like Stephen Hawking, have cautioned against sending signals into space, suggesting that it could be akin to shouting into a dark forest without knowing who or what might be listening. The risks, they argue, could outweigh the rewards, especially if an advanced civilization views us as a threat or a resource to be exploited. This debate also touches on deeper philosophical questions about humanity's place in the universe. Are we ready to engage with a civilization that might be vastly more advanced than our own? Do we have the wisdom to navigate such an encounter responsibly? These questions challenge us to reflect on our own values, priorities, and readiness as a species. They remind us that the act of sending a message is not just a scientific endeavor, but a profound statement about who we are and what we hope to achieve. Moreover, the Arecibo message highlights the challenges of communication across vast cultural and biological divides. Even if an extraterrestrial civilization were to receive and decode the message, would they understand its meaning? The symbols and concepts we consider universal might be entirely alien to them. This raises the question of whether our attempts at communication are inherently limited by our own perspectives and experiences. As we ponder these questions, it's clear that the Arecibo message is more than just a scientific experiment. It's a mirror reflecting our hopes, fears, and aspirations as a species. It challenges us to think critically about our role in the cosmos and the legacy we wish to leave behind. Whether or not we should continue sending messages into space remains an open question, but one thing is certain: the conversation it has sparked will continue to shape our approach to the search for extraterrestrial intelligence. With these thoughts in mind, let's turn our attention to another intriguing signal that has captured the imagination of scientists and dreamers alike. A signal that, like the Arecibo message, invites us to consider the mysteries and possibilities of the universe. Now, shifting our gaze to another enigmatic signal from the cosmos, we encounter the Shklovsky star signal, a mysterious radio emission that captivated scientists in the 1960s. This signal, originating from a distant star, stood out due to its unusual characteristics. Unlike typical cosmic radio waves, which often follow predictable patterns, the Shklovsky star signal exhibited irregularities that sparked immediate intrigue. Its fluctuations were so peculiar that some researchers initially speculated it could be artificial, a potential sign of intelligent life attempting to communicate across the vastness of space. The idea that this signal might be of extraterrestrial origin was not without merit. At the time, the search for extraterrestrial intelligence was gaining momentum, and any anomaly in the cosmic noise was scrutinized with great excitement. The Shklovsky star signal seemed to fit the bill, as its irregularities defied easy explanation. Could this be the long-awaited evidence of another civilization reaching out to us? The possibility fueled both scientific curiosity and public imagination, leading to a flurry of investigations and debates. However, as with many mysteries in the cosmos, the truth turned out to be more complex and more natural than initially thought. Further analysis revealed that the signal's irregularities could be attributed to a rare but natural astrophysical phenomenon. Specifically, it was linked to the interaction of cosmic rays with interstellar plasma, a process that can produce highly variable radio emissions. While this explanation ruled out the possibility of an artificial origin, it did not diminish the signal's significance. Instead, it highlighted the incredible diversity of natural processes that can occur in the universe, many of which remain poorly understood. Despite its natural explanation, the Shklovsky star signal remains a fascinating case in the annals of cosmic mysteries. It serves as a reminder of how easily our interpretations can be shaped by hope and imagination, and how the universe often surprises us with phenomena that challenge our understanding. This signal also underscores the importance of rigorous scientific investigation, as it was only through careful analysis that its true nature was uncovered. The story of the Shklovsky star signal invites us to reflect on the delicate balance between skepticism and optimism in the search for extraterrestrial intelligence. While it may not have been the alien message some had hoped for, it deepened our appreciation for the complexity of the cosmos and the need to approach such discoveries with both curiosity and caution. As we continue to explore the universe, signals like this remind us that every anomaly, whether natural or artificial, has the potential to teach us something new about the vast, mysterious expanse beyond our world. With this intriguing case in mind, let's now turn our attention to another cosmic puzzle that has puzzled astronomers and sparked endless speculation, a star whose strange behavior has led some to wonder if we might be witnessing the work of an advanced alien civilization. Now let's journey to a star that has baffled astronomers and ignited imaginations like few others, KIC 8462852, better known as Tabby star. This distant star, located over 1,000 light-years away, has become famous for its bizarre and unpredictable dimming patterns. Unlike most stars which dim in regular, predictable cycles, Tabby's star experiences sudden and dramatic drops in brightness, sometimes by as much as 22%. These unusual fluctuations have left scientists scratching their heads and sparked a wave of theories, some of which venture into the realm of science fiction. One of the most intriguing explanations for these strange dimming patterns is the idea of a Dyson sphere, a hypothetical megastructure built by an advanced alien civilization. Proposed by physicist Freeman Dyson in the 1960s, a Dyson sphere is a massive construct designed to capture a star's energy, potentially explaining the irregular dimming of Tabby's star. If such a structure were real, it would represent a monumental leap in technological achievement, far beyond anything humanity has ever conceived. The idea that we might be witnessing the work of an alien civilization has understandably captured the public's imagination, but it's important to approach this theory with a healthy dose of skepticism. While the Dyson sphere hypothesis is fascinating, scientists have also proposed more natural explanations for Tabby's star's behavior. One leading theory suggests that the dimming could be caused by a massive cloud of dust or debris orbiting the star. This debris could be the remnants of a shattered planet or comet, creating irregular patterns as it passes in front of the star from our perspective. Another possibility is that the star itself is undergoing unusual internal processes, such as magnetic activity or stellar pulsations, which could account for the erratic changes in brightness. Despite these natural explanations, the mystery of Tabby's star remains unsolved. Ongoing observations using advanced telescopes and instruments continue to monitor the star, searching for clues that could shed light on its strange behavior. Each new observation brings us closer to understanding whether we're witnessing a natural cosmic phenomenon or something far more extraordinary. The search for answers has also inspired new methods of analyzing starlight, helping astronomers refine their techniques for detecting unusual patterns in other stars. Tabby's star serves as a powerful reminder of how much we still have to learn about the universe. Whether its dimming is caused by natural processes or the handiwork of an advanced civilization, this enigmatic star challenges our understanding and pushes the boundaries of what we thought was possible. As we continue to study it, we're reminded that the cosmos is full of surprises, and sometimes the most extraordinary discoveries come from the most unexpected places. With this cosmic puzzle still unfolding, let's now turn our attention to another star system that has captured the curiosity of astronomers, a place where mysterious signals have sparked both excitement and debate. The search for megastructures like the hypothetical Dyson sphere has opened up a fascinating new frontier in astronomy. These colossal constructs, theorized to harness the energy of entire stars, could leave behind telltale signs in the form of unusual light patterns. While Tabby's star remains the most famous candidate, astronomers have identified other stars with similarly puzzling behavior, raising the possibility that advanced alien civilizations might be out there, reshaping their cosmic environments. One such star is Epoch 2043761, located about 1,500 light-years away. Like Tabby's star, it exhibits irregular and dramatic dips in brightness, sometimes dropping by as much as 80%. These extreme fluctuations have led some researchers to speculate that a swarm of megastructures, perhaps even a partially completed Dyson sphere, could be orbiting the star. While natural explanations such as dust clouds or planetary debris remain more likely, the sheer scale of these dimming events keeps the megastructure hypothesis alive. Another intriguing candidate is V1333 Cygni, a star that has shown unusual dimming patterns over several decades. Unlike most variable stars which dim and brighten in predictable cycles, V1333 Cygni's behavior is erratic and difficult to explain. Some scientists have suggested that its light patterns could be consistent with the presence of massive, artificial objects in orbit, though this remains speculative. The star's long history of observation makes it a valuable case study for understanding how megastructures might manifest in the cosmos. Detecting these potential megastructures requires a combination of advanced technology and creative thinking. Astronomers rely on telescopes like the Kepler Space Telescope and the Transiting Exoplanet Survey Satellite, or TESS, to monitor stars for unusual light patterns. By analyzing the precise timing, depth, and shape of these dips, researchers can distinguish between natural phenomena like planets or dust clouds and potential artificial structures. For example, a megastructure might produce asymmetrical or irregular dips in brightness, unlike the smooth, symmetrical patterns caused by planets. Beyond light patterns, scientists are also exploring other ways to detect megastructures. One approach involves looking for excess infrared radiation, which could indicate waste heat from an energy-harvesting structure. Another method focuses on searching for unusual orbital dynamics, such as the gravitational influence of massive objects that don't behave like natural bodies. These techniques, combined with ongoing advancements in telescope technology, are helping astronomers refine their search for signs of alien engineering. While the idea of megastructures is undeniably exciting, it's important to approach these discoveries with caution. Many of the unusual light patterns observed so far can be explained by natural phenomena such as swarms of comets, clouds of interstellar dust, or even the star's own internal processes. However, the search for megastructures pushes us to think creatively and consider possibilities that were once the realm of science fiction. It challenges us to expand our understanding of what might be possible in the universe and to remain open to the extraordinary. As we continue to explore the cosmos, stars like Tabby's star and Epoch 2043769-1 remind us that the universe is full of mysteries waiting to be unraveled. Whether these enigmatic light patterns are the result of natural processes or the handiwork of advanced civilizations, they inspire us to keep looking, keep questioning, and keep dreaming. And with each new discovery, we take one step closer to answering one of humanity's oldest questions. Are we alone in the universe? Now, let's shift our gaze to another intriguing signal that has sparked both excitement and debate, a mysterious radio burst that has left scientists searching for answers. Turning our attention to another fascinating signal, we come to the story of the HD 164595 signal, a mysterious radio burst that captured the world's attention in 2016. Detected by the Ratan 600 radio telescope in Russia, this signal stood out for its strength and unusual characteristics. Originating from a star system approximately 95 light-years away, HD 164595 quickly became a focal point of speculation. Could this be the long-awaited evidence of extraterrestrial intelligence? The excitement surrounding the signal was palpable. Scientists noted that the signal appeared to be narrowband, a feature often associated with artificial transmissions rather than natural cosmic phenomena. Narrowband signals are particularly intriguing because they require precise engineering, something that natural processes rarely produce. This led to widespread speculation that the signal might be a deliberate attempt at communication from an advanced civilization. The star itself, HD 164595, added to the intrigue. It's a sun-like star, and astronomers had already identified a Neptune-sized exoplanet orbiting within its system, raising the possibility of a habitable environment. However, as with many tantalizing discoveries in the search for extraterrestrial intelligence, the initial excitement was tempered by further investigation. Researchers soon discovered that the signal's characteristics closely matched those of human-made interference, likely originating from Earth-based sources such as satellites or military equipment. This revelation was a sobering reminder of the challenges faced in distinguishing between potential alien messages and the ever-present noise of human activity. Despite the eventual explanation, the HD 164595 signal remains a cautionary tale in the search for extraterrestrial intelligence. It highlights the importance of rigorous verification and the need to rule out all possible terrestrial explanations before jumping to conclusions about alien contact. At the same time, it underscores the excitement and hope that drive this field of research. Every signal, even those ultimately explained as interference, brings us closer to refining our methods and improving our ability to detect genuine extraterrestrial messages. The story of HD 164595 also serves as a reminder of the broader context in which these searches take place. The universe is vast, and the signals we detect are often faint and ambiguous. Yet, each one offers a glimpse into the possibilities that lie beyond our solar system. Whether natural or artificial, these signals challenge us to think creatively and push the boundaries of our understanding. As we continue our journey through the cosmos, the HD 164595 signal stands as a testament to the enduring allure of the unknown. It reminds us that the search for extraterrestrial intelligence is as much about the questions we ask as the answers we find. And with each new discovery, we inch closer to unraveling one of the greatest mysteries of all. Are we alone in the universe? Now, let's explore another intriguing signal, this time from the closest star system to our own Proxima Centauri. Now, shifting our gaze to the closest star system to our own, we encounter the enigmatic Proxima Centauri signal. Detected in 2020, this mysterious radio burst immediately captured the attention of astronomers and alien hunting enthusiasts alike. Proxima Centauri, located just over 4 light-years from Earth, is already a star of great interest due to its proximity and the presence of Proxima b, an exoplanet within its habitable zone. The discovery of a potential signal from this system added a new layer of intrigue to an already fascinating cosmic neighbor. The signal, detected by the Breakthrough Listen project, stood out for its narrowband nature, a characteristic often associated with artificial transmissions. Unlike the chaotic bursts of natural cosmic phenomena, narrowband signals suggest precision and intent, qualities that naturally lead to speculation about intelligent origins. This particular signal appeared to originate from the direction of Proxima Centauri, making it one of the most tantalizing candidates for extraterrestrial communication ever detected. However, the excitement surrounding the signal was met with cautious skepticism. Scientists quickly pointed out the challenges of confirming its origin. Proxima Centauri is not only close to Earth but also lies in a region of the sky that is heavily trafficked by human-made satellites and other sources of interference. The possibility that the signal could be a product of Earth-based technology or a passing satellite could not be ruled out. This ambiguity highlights the delicate balance between hope and rigor in the search for extraterrestrial intelligence. The investigation into the Proxima Centauri signal is ongoing, with researchers meticulously analyzing its characteristics to determine whether it could indeed be a message from another civilization. The process involves ruling out all possible terrestrial and natural explanations, a task that requires both patience and precision. Even if the signal is ultimately explained as interference, its detection serves as a valuable case study in refining our methods and improving our ability to distinguish between potential alien messages and the noise of human activity. What makes the Proxima Centauri signal particularly compelling is the context of its discovery. Proxima b, the exoplanet orbiting within the star's habitable zone, has long been a target in the search for extraterrestrial life. If the signal were confirmed to be of artificial origin, it would raise profound questions about the possibility of life, and perhaps even intelligent life so close to our own solar system. The implications would be staggering, reshaping our understanding of the universe and our place within it. As we await further findings, the Proxima Centauri signal reminds us of the enduring allure of the unknown. It challenges us to remain both hopeful and critical, balancing our desire for discovery with the need for scientific rigor. Whether this signal turns out to be a message from another civilization or another false alarm, it underscores the importance of continuing the search. After all, the next signal we detect could be the one that changes everything. With this in mind, let's turn our attention to another intriguing case, the strange signal detected from the star Ross 128 in 2017. Now, let's take a closer look at the possibility of life in the Proxima Centauri system, a topic that adds even more weight to the mystery of the signal we just discussed. Proxima Centauri, our closest stellar neighbor, is home to Proxima b, an exoplanet that orbits within the star's habitable zone. This region, often referred to as the Goldilocks zone, is where conditions might be just right for liquid water to exist, a key ingredient for life as we know it. The discovery of Proxima b in 2016 sparked excitement among scientists and space enthusiasts alike, as it represents one of the most promising targets in the search for extraterrestrial life. Proxima b is roughly 1.3 times the mass of Earth, making it a rocky planet similar in size to our own. Its proximity to Proxima Centauri means it completes an orbit in just 11.2 Earth days. But despite this close distance, it remains within the habitable zone because Proxima Centauri is a red dwarf star, much cooler and dimmer than our Sun. However, this proximity comes with challenges. Red dwarfs are known for their intense stellar activity, including powerful flares that could bombard Proxima b with harmful radiation. This raises questions about whether life could survive on the planet's surface, or if it would need to find refuge underground or beneath protective layers of water. The potential for life on Proxima b is further complicated by its tidal locking, a phenomenon where one side of the planet always faces the star, creating permanent day and night sides. While this might seem like a barrier to life, some scientists speculate that a thick atmosphere or vast oceans could redistribute heat, creating more temperate conditions. If life does exist on Proxima b, it might be vastly different from anything we've encountered on Earth, adapted to the unique challenges of its environment. The implications of finding a signal from Proxima Centauri are profound. If the signal were confirmed to be of artificial origin, it would suggest that intelligent life could exist just 4 light-years away, a cosmic stone's throw in astronomical terms. This would not only revolutionize our understanding of life in the universe, but also raise urgent questions about how we might communicate with or even visit such a nearby civilization. The idea that we might not be alone in the universe would shift from a philosophical musing to a tangible reality. Even if the signal turns out to be natural or human-made, the Proxima Centauri system remains a beacon of hope in the search for life. Its proximity makes it an ideal candidate for future missions, such as the proposed Breakthrough Starshot project, which aims to send tiny probes to the system within our lifetimes. These missions could provide unprecedented insights into Proxima b and its potential to host life, bringing us closer to answering one of humanity's oldest questions: are we alone? As we continue to explore the mysteries of Proxima Centauri, we are reminded of the delicate balance between curiosity and caution. The search for life, whether microbial or intelligent, requires both optimism and rigorous scientific scrutiny. Each discovery, each signal, brings us one step closer to understanding our place in the cosmos. And with Proxima Centauri so tantalizingly close, the answers we seek might be closer than we think. Now let's turn our attention to another intriguing signal, this time from the star Ross 128, where another cosmic mystery awaits. Moving from the mysteries of Proxima Centauri, we now turn our gaze to another star that has captured the attention of astronomers, Ross 128. In 2017, a peculiar signal was detected from this red dwarf star, located just 11 light-years from Earth. The signal, observed by the Arecibo Observatory, stood out due to its unusual properties. Unlike the random noise typically picked up from distant stars, this signal appeared to have a distinct pattern, sparking immediate curiosity and speculation. The signal from Ross 128 was detected at a frequency of around 4.7 GHz, a range often associated with human-made technology. This led to initial excitement that it could be a deliberate transmission from an extraterrestrial civilization. The idea was further fueled by the fact that Ross 128 is a relatively quiet star with minimal stellar activity, making it an unlikely source of natural radio emissions. For a brief moment, it seemed like we might be on the verge of a groundbreaking discovery. However, as scientists dug deeper, a more mundane explanation emerged. The signal was eventually attributed to interference from one or more geostationary satellites orbiting Earth. These satellites, which are used for communication and broadcasting, often emit signals at frequencies similar to those detected from Ross 128. While this explanation tempered the initial excitement, it didn't entirely dismiss the intrigue surrounding the signal. The fact that it was so easily mistaken for something extraordinary highlights the challenges of distinguishing between natural, human-made, and potentially alien signals in the vast sea of cosmic noise. What makes the Ross 128 signal particularly fascinating is the way it underscores the complexities of the search for extraterrestrial intelligence. Even with advanced technology and rigorous analysis, the line between a groundbreaking discovery and a false alarm can be razor thin. This case serves as a reminder of the importance of skepticism and thorough investigation in the field of astronomy. It also raises questions about how we might better filter out interference in the future, ensuring that genuine signals don't slip through the cracks. Despite its earthly origins, the Ross 128 signal remains a compelling case study in the search for alien messages. It reminds us that the universe is full of surprises, and even the most promising leads can take unexpected turns. As we continue to explore the cosmos, signals like this one keep us on our toes, challenging us to refine our methods and remain open to the possibility that one day we might find something truly extraordinary. Now, let's shift our focus to another cosmic enigma, the gliese 581G signal, where the debate over its existence adds yet another layer to the mystery of deep space. Now, let's journey to a star system that has sparked both excitement and skepticism in the scientific community, gliese 581. This red dwarf star, located approximately 20 light-years from Earth, is home to a potentially habitable exoplanet known as gliese 581G. Discovered in 2010, this planet quickly became a focal point of interest due to its position within the star's habitable zone, where conditions might allow for liquid water to exist. But what truly captured the imagination of astronomers and the public alike was the faint signal that some believed could be a sign of extraterrestrial activity. The gliese 581G signal emerged from observations made by researchers searching for signs of life beyond our solar system. The signal, though faint, appeared to have a pattern that stood out from the usual background noise of space. This led to speculation that it could be a deliberate transmission from an intelligent civilization on or near the planet. The idea was tantalizing, a world that might support life, possibly sending out a message to the cosmos. However, the signal's faintness and the immense distance made it incredibly difficult to confirm its origin or even its existence. The debate over the gliese 581G signal highlights one of the greatest challenges in the search for extraterrestrial intelligence, interpreting faint signals from distant stars. On one hand, the signal's potential alignment with a habitable planet made it a compelling candidate for further investigation. On the other hand, the possibility of it being a random fluctuation or interference from Earth-based sources could not be ruled out. This uncertainty has divided scientists, with some arguing that the signal deserves more attention, while others remain skeptical, emphasizing the need for more robust evidence. Adding to the complexity is the fact that gliese 581G itself is a controversial discovery. Some astronomers question whether the planet even exists, as its detection relies on subtle changes in the star's motion that are difficult to measure with certainty. If the planet's existence is confirmed, it would be one of the most Earth-like worlds discovered to date, with a mass and orbit that could support stable conditions for life. But until then, the signal remains a mystery caught between the realms of possibility and doubt. What makes the gliese 581G signal so intriguing is not just its potential origin, but what it represents in our quest to understand the universe. It reminds us that the search for extraterrestrial intelligence is filled with uncertainties and challenges, requiring patience, precision, and an open mind. As we continue to explore the cosmos, signals like this one push us to refine our methods and remain vigilant, always ready for the possibility that we might one day find a message from the stars. Next, we'll delve into another fascinating signal, the BLC-1 signal, where the line between human-made interference and potential alien communication becomes even more blurred. Shifting our focus to a more recent and equally intriguing mystery, let's explore the BLC-1 signal, a detection that has sparked both excitement and caution in the search for extraterrestrial intelligence. Discovered in 2020, this signal was picked up by the Breakthrough Listen project, a global initiative dedicated to scanning the cosmos for signs of alien life. What made BLC-1 stand out was its origin. It appeared to come from the direction of Proxima Centauri, the closest star system to Earth, located just over 4 light-years away. This proximity alone made the signal a prime candidate for further investigation. The BLC-1 signal was unique in several ways. Unlike many other potential extraterrestrial signals, it was narrowband, meaning it occupied a very specific frequency range. This is significant because natural cosmic phenomena, such as pulsars or fast radio bursts, typically produce signals across a wide range of frequencies. A narrowband signal, on the other hand, is often considered a hallmark of artificial origin, as it resembles the kind of deliberate transmission an advanced civilization might produce. Additionally, the signal exhibited a drift in frequency, which could suggest it was emitted by a moving source, such as a planet or spacecraft. When the BLC-1 signal was first detected, it generated considerable excitement among researchers. The fact that it originated from the direction of Proxima Centauri, a star system known to host at least one potentially habitable exoplanet, added to its allure. Could this be a message from a neighboring civilization? The possibility was tantalizing, but scientists were quick to temper their enthusiasm with caution. The Breakthrough Listen team emphasized the need for rigorous analysis to rule out more mundane explanations, such as interference from human-made technology or natural cosmic noise. As the investigation unfolded, the signal's extraterrestrial origins became less certain. One of the leading theories suggested that BLC-1 might have been caused by interference from Earth-based sources, such as satellites or ground-based equipment. This is a common challenge in the search for extraterrestrial intelligence, distinguishing between genuine cosmic signals and human-made noise. Despite extensive efforts to confirm the signal's origin, no definitive conclusion has been reached. The BLC-1 signal remains a fascinating enigma, caught between the realms of possibility and skepticism. What makes BLC-1 particularly compelling is the broader context of the search for extraterrestrial intelligence. It serves as a reminder of the delicate balance between hope and caution in this field. While the signal's characteristics make it a strong candidate for further study, the lack of conclusive evidence underscores the challenges of interpreting faint, distant signals. As technology advances and our methods of detection improve, signals like BLC-1 will continue to push the boundaries of our understanding, keeping the dream of contact with an alien civilization alive. Now, let's turn our attention to another mysterious signal that has puzzled scientists for decades, the Rattan 600 signal, a detection that has raised questions about the nature of cosmic phenomena and the limits of our technology. The challenges of verifying potential extraterrestrial signals are immense, requiring a meticulous and often painstaking process. When a signal like BLC-1 is detected, the first step is to rule out any possibility of human-made interference. This involves cross-checking the signal against known sources of radio emissions, such as satellites, aircraft, or even ground-based equipment. Even the slightest overlap in frequency or timing can cast doubt on a signal's extraterrestrial origin. For instance, signals from satellites or cell towers can sometimes mimic the narrowband characteristics that make a detection seem promising. This is why researchers must approach every potential discovery with a healthy dose of skepticism. Beyond human-made interference, natural cosmic phenomena also present significant hurdles. Pulsars, fast radio bursts, and even the faint hum of distant galaxies can produce signals that at first glance appear artificial. Distinguishing between these natural sources and a genuine extraterrestrial transmission requires advanced technology and a deep understanding of astrophysics. For example, the drift in frequency observed in the BLC-1 signal could be caused by the Doppler effect, a phenomenon that occurs when a source of waves is moving relative to an observer. While this drift initially suggested a moving extraterrestrial source, it could also be explained by natural processes, such as the rotation of a planet or the movement of a distant star. The verification process often involves multiple stages of analysis, including repeated observations and cross-referencing data from different instruments. If a signal cannot be detected again, its credibility diminishes significantly. This was the case with the WOW signal, which, despite its strong initial detection, has never been observed again. The inability to replicate a signal makes it nearly impossible to confirm its extraterrestrial origin, leaving scientists with more questions than answers. This underscores the importance of patience and persistence in the search for alien messages. Skepticism plays a crucial role in this field, acting as a safeguard against premature conclusions. While the idea of discovering an extraterrestrial signal is undeniably exciting, scientists must remain objective and methodical in their approach. Every potential discovery is subjected to rigorous scrutiny, with researchers actively seeking alternative explanations before considering the possibility of alien intelligence. This cautious approach ensures that only the most credible signals are pursued further, maintaining the integrity of the search for extraterrestrial intelligence. As we continue to refine our methods and expand our technological capabilities, the challenges of signal verification will remain a central focus. Each new detection, whether it turns out to be a false alarm or a genuine mystery, brings us closer to understanding the complexities of the cosmos. The search for extraterrestrial intelligence is not just about finding answers, it's about asking the right questions and being prepared for the unexpected. With that in mind, let's turn our attention to another fascinating signal that has captivated scientists and enthusiasts alike. The Rattan 600 signal, a detection that has raised intriguing questions about the nature of cosmic phenomena and the limits of our technology. Now, let's shift our focus to a signal that sparked both excitement and debate: the Rattan 600 signal. Detected in 2016 by the Rattan 600 radio telescope in Russia, this signal stood out for its remarkable strength and unusual characteristics. Originating from a star system located approximately 94 light-years away, the signal immediately caught the attention of scientists and enthusiasts alike. Its narrowband nature, a hallmark of potential artificial transmissions, fueled speculation that it could be a deliberate attempt at communication from an extraterrestrial civilization. The initial excitement surrounding the Rattan 600 signal was palpable. Researchers noted that its frequency and intensity were unlike typical cosmic noise, raising hopes that it might be the breakthrough the scientific community had been waiting for. The star system it came from, known as HD 164595, added to the intrigue. This star is similar in size and temperature to our own Sun, and it hosts at least one known exoplanet, making it a prime candidate for harboring life. The combination of these factors led to a flurry of activity as scientists scrambled to analyze the signal further. However, as with many promising detections, the story took a turn. Upon closer examination, researchers discovered that the signal's properties could be explained by natural phenomena. One leading theory suggests that the signal may have been caused by a passing satellite or other human-made interference, a common challenge in the search for extraterrestrial intelligence. Another possibility is that it originated from a natural astrophysical process, such as a burst of energy from a distant star or galaxy. Despite these explanations, the Rattan 600 signal remains a fascinating case study in the complexities of signal detection and interpretation. What makes this signal particularly intriguing is the way it highlights the fine line between hope and skepticism in the search for alien messages. While it ultimately did not prove to be of extraterrestrial origin, it served as a reminder of the challenges scientists face in distinguishing between natural and artificial signals. The Rattan 600 signal also underscores the importance of advanced technology and rigorous analysis in this field. Each detection, whether confirmed or debunked, contributes to our understanding of the cosmos and refines our methods for future searches. As we continue to explore the mysteries of deep space, signals like the Rattan 600 remind us of the vastness of the universe and the potential for discovery that lies within it. They challenge us to remain both curious and cautious, balancing our excitement with a commitment to scientific rigor. And with that, we turn our attention to another enigmatic signal, one that comes from a star system even closer to home, raising new questions about the possibility of life beyond Earth. Now, let's journey to a star system that has captured the imagination of astronomers and space enthusiasts alike: Kepler 438b. This exoplanet, located roughly 640 light-years from Earth, orbits within the habitable zone of its star, making it one of the most promising candidates for potentially hosting life. The Kepler 438b signal, detected by the Kepler Space Telescope, has sparked significant interest due to its unusual characteristics and the tantalizing possibility that it could be linked to extraterrestrial activity. Kepler 438b is a rocky planet slightly larger than Earth, and it receives just enough starlight to allow for the presence of liquid water, a key ingredient for life as we know it. The signal associated with this exoplanet is intriguing because it doesn't fit neatly into the patterns of natural astrophysical phenomena. Instead, it exhibits fluctuations that are difficult to explain using conventional models. Some scientists have speculated that these irregularities could be the result of advanced alien technology, such as massive structures or energy harvesting devices orbiting the planet. While this idea remains speculative, it has fueled excitement and debate within the scientific community. However, interpreting signals from such distant worlds is no easy task. The vast distance between Earth and Kepler 438b means that any signal we detect is incredibly faint and subject to interference from cosmic noise. Additionally, the star itself is prone to intense stellar activity, including powerful flares that can obscure or mimic potential signals. These challenges make it difficult to determine whether the observed anomalies are truly signs of extraterrestrial intelligence or simply the result of natural processes. Despite these hurdles, the Kepler 438b signal serves as a reminder of the incredible potential for discovery in our universe. It highlights the importance of continued observation and the development of more sensitive instruments capable of distinguishing between natural and artificial signals. Each detection, whether confirmed or debunked, brings us one step closer to understanding the complexities of distant star systems and the possibility of life beyond our own planet. As we move forward, the mysteries surrounding Kepler 438b continue to inspire both curiosity and caution. They remind us that the search for extraterrestrial intelligence is as much about refining our methods as it is about making groundbreaking discoveries. And with that, we turn our attention to another fascinating signal, one that takes us even deeper into the enigmatic realm of deep space. Now, let's step back in time to one of the most fascinating moments in the history of space exploration, the discovery of the LGM-1 signal. This signal, detected in 1967, marked a pivotal moment in our understanding of the cosmos, but it also came with a twist that left scientists both puzzled and intrigued. At first, the signal appeared so regular and precise that it seemed almost impossible to be natural. In fact, the researchers who discovered it jokingly nicknamed it LGM-1, short for Little Green Men 1, as they seriously considered the possibility that it might be a message from an extraterrestrial civilization. The LGM-1 signal was unlike anything astronomers had ever encountered. It pulsed with remarkable consistency, repeating every 1.337 seconds. This rhythmic pattern was so precise that it defied explanation by known natural phenomena. For a brief moment, the idea of an alien intelligence sending a deliberate signal to Earth seemed like a plausible explanation. The Discovery team, led by astrophysicist Jocelyn Bell Burnell, even entertained the thought that they might have stumbled upon evidence of extraterrestrial life. However, as further observations were made, the true nature of the signal began to reveal itself. What scientists eventually realized was that the LGM-1 signal was not a message from aliens but the first detection of a pulsar, a rapidly rotating neutron star emitting beams of electromagnetic radiation. These beams sweep across space like a cosmic lighthouse, creating the regular pulses that were initially mistaken for an artificial signal. The discovery of pulsars revolutionized our understanding of stellar evolution and the extreme conditions that exist in the universe. It also served as a humbling reminder of how much we still have to learn about the cosmos. The story of the LGM-1 signal teaches us an important lesson about the search for extraterrestrial intelligence. It highlights the need for careful analysis and skepticism when interpreting unusual signals from space. While the initial excitement over the possibility of alien contact was understandable, the eventual explanation demonstrated the power of scientific rigor in uncovering the truth. This discovery also paved the way for future research into pulsars, which have since become invaluable tools for studying the universe, from testing the limits of physics to mapping the structure of our galaxy. As we reflect on the LGM-1 signal, it's a reminder that the universe is full of surprises, and sometimes what seems like a message from another world turns out to be a natural phenomenon waiting to be understood. This story not only deepened our knowledge of the cosmos, but also set the stage for the next chapter in our exploration of deep space. And with that, we turn our attention to another intriguing signal, one that continues to challenge our understanding of the universe. Now, let's shift our focus to a signal that has baffled scientists and sparked endless speculation: the FRB 121102 repeater. This fast radio burst, first detected in 2012, stands out as the first of its kind to repeat, sending out multiple bursts over time rather than a single, fleeting signal. Its discovery opened up a new chapter in the study of these mysterious cosmic phenomena, raising questions that continue to challenge our understanding of the universe. What makes FRB 121102 so extraordinary is its repeating nature. Unlike most fast radio bursts, which are one-off events lasting just milliseconds, this signal has been observed emitting multiple bursts over several years. These bursts are incredibly powerful, releasing as much energy in a fraction of a second as the sun does in an entire day. Yet, despite their intensity, their origin remains shrouded in mystery. The bursts come from a dwarf galaxy located approximately 3 billion light-years away, adding another layer of intrigue to the puzzle. Scientists have proposed various theories to explain the source of FRB 121102. One leading idea is that it could be linked to a highly magnetized neutron star known as a magnetar. These dense, rapidly spinning stellar remnants are capable of producing intense bursts of energy, which might account for the repeating signals. However, the exact mechanism behind these bursts is still unclear, leaving room for alternative explanations. Some researchers have even speculated that the signal could be evidence of advanced alien technology, such as a massive energy source or a communication device designed to span the vast distances of space. The debate over the origin of FRB 121102 highlights the challenges of interpreting signals from deep space. While natural explanations are often the most plausible, the possibility of extraterrestrial intelligence cannot be entirely ruled out. This uncertainty fuels ongoing research as scientists continue to monitor the signal and search for patterns that might reveal its true nature. The discovery of additional repeating fast radio bursts has only deepened the mystery, suggesting that FRB 121102 may be just one example of a broader cosmic phenomenon. As we explore the enigma of FRB 121102, it serves as a reminder of how much we still have to learn about the universe, whether it's the product of a natural cosmic event or a sign of alien technology. This signal challenges us to think beyond our current understanding and consider the extraordinary possibilities that lie hidden in the depths of space. And with that, we turn our attention to another intriguing mystery, one that takes us even closer to the stars. Now, let's journey to a star system that has captured the imagination of astronomers and space enthusiasts alike, the TRAPPIST-1 system. Located just under 40 light-years from Earth, this ultra-cool dwarf star is home to 7 rocky planets, 3 of which orbit within its habitable zone. This makes TRAPPIST-1 one of the most promising places to search for signs of life beyond our solar system. But what truly sets this system apart are the mysterious signals that have been detected emanating from its planets, sparking both excitement and intrigue. The TRAPPIST-1 system was first discovered in 2017, and its planets quickly became a focal point for scientists studying exoplanets. What makes these worlds so fascinating is their potential to host liquid water, a key ingredient for life as we know it. However, the faint signals detected from these planets have added another layer of mystery. These signals, which appear as subtle variations in light and radio waves, have raised questions about their origins. Could they be natural phenomena, such as atmospheric activity or geological processes? Or might they hint at something more extraordinary, like the presence of life or even advanced civilizations? Interpreting these signals is no easy task. The planets in the TRAPPIST-1 system are incredibly distant, and the signals we detect are faint and often ambiguous. Scientists must carefully analyze the data to distinguish between natural causes and potential signs of life. For example, certain chemical signatures in a planet's atmosphere, such as oxygen or methane, could indicate biological activity. However, these same gases can also be produced by non-living processes, making it difficult to draw definitive conclusions. This challenge underscores the complexity of searching for life in the cosmos and the need for advanced technology to gather more precise data. Despite these challenges, the TRAPPIST-1 system remains a beacon of hope in the search for extraterrestrial life. Its proximity to Earth and the unique characteristics of its planets make it an ideal target for future missions, such as the James Webb Space Telescope, which could provide unprecedented insights into these distant worlds. As we continue to study the signals from TRAPPIST-1, we are reminded of the vast possibilities that lie beyond our own solar system and the enduring question of whether we are alone in the universe. With the mysteries of TRAPPIST-1 still unfolding, we now turn our attention to another enigmatic object that has puzzled scientists, a visitor from beyond our solar system that defies easy explanation. Now, let's shift our gaze to an object that has sparked both fascination and debate: Oumuamua, the first known interstellar visitor to our solar system. Discovered in October 2017, this mysterious object defied expectations from the moment it was spotted. Unlike anything we've seen before, Oumuamua's unusual shape and behavior left scientists scrambling for explanations. Measuring roughly 400 meters in length but only about 40 meters wide, its elongated, cigar-like form was unlike any asteroid or comet observed in our solar system. But it wasn't just its shape that caught attention, it was how it moved. As Oumuamua traveled through our solar system, it exhibited unexpected acceleration, something that couldn't be fully explained by gravity alone. This peculiar behavior led some researchers to propose that it might be propelled by an artificial force, such as a light sail, a technology theorized for interstellar travel. The idea that Oumuamua could be an alien spacecraft, perhaps a probe sent by an advanced civilization, captured the public's imagination and ignited a wave of speculation. Could this strange object be evidence of extraterrestrial intelligence, or was it simply a natural phenomenon we didn't yet understand? Scientists have since proposed several natural explanations for Oumuamua's behavior. One theory suggests that it might be a fragment of a larger object, perhaps a piece of a planet or a comet, ejected from another star system. Another possibility is that outgassing, the release of gas from its surface, could have caused its unusual acceleration. However, no definitive evidence has been found to confirm these theories, leaving the mystery of Oumuamua's true nature unresolved. What makes Oumuamua so intriguing is not just its origin but what it represents. As the first confirmed interstellar object to pass through our solar system, it opened a new chapter in our understanding of the cosmos. It reminded us that the universe is full of surprises and that objects from distant star systems could be far more common than we once thought. While the debate over Oumuamua's identity continues, its discovery has inspired scientists to keep a closer watch on the skies, hoping to catch another interstellar visitor that might provide more answers. As we ponder the enigma of Oumuamua, we're reminded of the vastness of space and the endless possibilities it holds. Could the next interstellar object we detect hold even greater mysteries? Only time and continued exploration will tell. Now, as we turn our attention to the broader search for interstellar objects, we find ourselves on the brink of a new frontier in space exploration. Oumuamua was just the beginning, a tantalizing glimpse into the possibility that our solar system is not as isolated as we once thought. Since its discovery, astronomers have been actively scanning the skies, hoping to find more of these cosmic travelers. But why is the search for interstellar objects so important? And what could they tell us about the universe beyond our own neighborhood? One of the most exciting aspects of interstellar objects is their potential to carry messages or even evidence of extraterrestrial intelligence. Imagine if an object like Oumuamua contained encoded information or technology from another civilization. While this idea remains speculative, it's not entirely far-fetched. Interstellar objects could serve as natural messengers, carrying materials or signals across vast distances of space. The challenge, of course, is detecting and studying these objects before they slip away, often traveling at incredible speeds. Studying interstellar objects is no easy task. They are typically small, fast-moving, and difficult to observe in detail. By the time we detect them, they're often already on their way out of the solar system, leaving us with only a brief window to gather data. This makes it crucial to develop advanced telescopes and detection methods capable of spotting these elusive visitors early. Projects like the Vera-C. Rubin Observatory, set to begin operations in the coming years, aim to revolutionize our ability to track and analyze interstellar objects, potentially uncovering more clues about their origins and nature. The search for interstellar objects also raises fascinating questions about the frequency of such visitors. Are they rare, or do they pass through our solar system more often than we realize? Some scientists estimate that there could be thousands of these objects in our solar system at any given time, most of which go unnoticed. If true, this would suggest that interstellar travel, whether by natural objects or artificial probes, is far more common than we've assumed. Each new discovery could bring us closer to understanding whether these objects are simply cosmic debris or something far more significant. Looking ahead, the possibility of future discoveries is both thrilling and humbling. Every new interstellar object we detect could hold the key to unlocking mysteries about the formation of star systems, the distribution of materials across the galaxy, or even the existence of extraterrestrial life. As our technology improves and our understanding deepens, we may one day find an object that definitively answers the question, are we alone in the universe? The search for interstellar objects is more than a scientific endeavor, it's a journey of curiosity and discovery. Each new visitor from the stars reminds us of the vastness of space and the endless possibilities it holds. As we continue to explore, who knows what secrets these cosmic travelers might reveal? The next interstellar object could be just around the corner, waiting to rewrite our understanding of the cosmos. Shifting our gaze to one of the most perplexing cosmic mysteries, we return to the enigmatic star known as Tabby's star, officially designated KIC 8462852. This star captured the world's attention with its bizarre and unpredictable dimming patterns, sparking a wave of speculation and scientific intrigue. Among the most controversial theories is the idea that these unusual light fluctuations could be evidence of a megastructure, a colossal artificial construct built by an advanced extraterrestrial civilization. But what exactly makes this hypothesis so compelling, and why does it continue to divide scientists? The megastructure hypothesis gained traction when astronomers observed that Tabby's star dimmed in irregular and dramatic ways, unlike anything seen in other stars. Some suggested that a massive swarm of orbiting objects, possibly a Dyson sphere or a similar megastructure, could be blocking the star's light. A Dyson sphere, a theoretical concept proposed by physicist Freeman Dyson, is a hypothetical structure designed to harness the energy of a star by surrounding it with solar collectors. If such a structure existed around Tabby's star, it could explain the unusual dimming patterns. This idea, while speculative, ignited imaginations and fueled debates about the possibility of advanced alien civilizations. However, not all scientists are convinced. Many argue that natural explanations are more plausible. One leading theory suggests that the dimming could be caused by a massive cloud of dust or debris orbiting the star. This dust could be the remnants of a shattered planet or comet, creating irregular patterns as it passes in front of the star. Another possibility is that the star itself is undergoing internal changes, such as magnetic activity or stellar pulsations, which could cause its brightness to fluctuate. While these explanations are less sensational than the megastructure hypothesis, they are grounded in well-understood astrophysical processes. The search for answers continues, with astronomers using advanced telescopes and instruments to study Tabby's star in greater detail. Observations from missions like the Kepler Space Telescope and the Transiting Exoplanet Survey satellite have provided valuable data, but the mystery remains unsolved. Each new observation brings us closer to understanding the true nature of this star, yet the question lingers: could there be a megastructure out there, or are we witnessing a rare but natural cosmic phenomenon? What makes Tabby's star so fascinating is not just the mystery itself, but what it represents. It challenges us to think beyond the boundaries of our current knowledge and consider the possibility of civilizations far more advanced than our own. Whether the answer lies in alien technology or natural processes, the investigation into Tabby's star reminds us of the boundless curiosity that drives humanity's exploration of the cosmos. As we continue to study this enigmatic star, we may uncover not only the truth behind its dimming, but also new insights into the universe itself. The next chapter in this cosmic mystery could be just one observation away. Turning our attention to another groundbreaking effort in the search for extraterrestrial intelligence, we now explore the SETI at Home project. This innovative initiative has revolutionized the way we analyze radio signals from deep space by harnessing the power of everyday computers around the world. Launched in the late 1990s, SETI at Home invited volunteers to contribute their computers' idle processing power to help sift through vast amounts of data collected by radio telescopes. The goal: to identify potential signals that could indicate the presence of intelligent life beyond Earth. Here's how it works. Radio telescopes, like the Arecibo observatory before its collapse, capture enormous amounts of data from the cosmos. This data contains countless radio signals, most of which are natural phenomena like pulsars or cosmic background noise. However, buried within this sea of information could be faint, artificial signals, messages from an alien civilization. Analyzing this data requires immense computational power, far beyond what a single research institution could provide. That's where SETI at home comes in. By distributing small chunks of data to volunteers' computers, the project effectively creates a global supercomputer capable of processing data at an unprecedented scale. The contributions of SETI at home have been remarkable. Over the years, millions of participants from more than 200 countries have joined the effort, collectively contributing billions of hours of computing time. This massive collaboration has allowed scientists to analyze data more thoroughly and efficiently than ever before. While no definitive alien signal has been discovered yet, the project has identified numerous intriguing candidates that warrant further investigation. More importantly, SETI at home has democratized the search for extraterrestrial intelligence, allowing anyone with a computer and an internet connection to become part of this cosmic quest. Beyond its scientific achievements, SETI at home has also inspired a new generation of citizen scientists. By engaging the public in real scientific research, the project has fostered a deeper appreciation for the mysteries of the universe and the importance of collaboration in solving them. It has also paved the way for other distributed computing projects, such as those focused on climate modeling, protein folding, and even the search for gravitational waves. As we look to the future, the legacy of SETI at home serves as a reminder of humanity's collective curiosity and ingenuity. While the search for alien messages continues, this project has shown us that the answers we seek may come not just from advanced technology, but from the combined efforts of people around the world, united by a shared sense of wonder. And as we move forward, the next breakthrough in our search for extraterrestrial intelligence could very well come from someone's living room, powered by a simple computer and an unyielding desire to explore the unknown. Building on the spirit of global collaboration we've just explored, let's now turn our attention to another ambitious project in the search for extraterrestrial intelligence, the Breakthrough Listen initiative. Launched in 2015, this groundbreaking effort represents one of the most comprehensive and technologically advanced searches for alien signals ever undertaken. Funded by billionaire Yuri Milner and backed by renowned scientists like Stephen Hawking, Breakthrough Listen aims to answer one of humanity's most profound questions: are we alone in the universe? The initiative's goals are as bold as they are inspiring. Over the course of 10 years, Breakthrough Listen is scanning the skies for signs of intelligent life, focusing on the 1 million closest stars, the 100 nearest galaxies, and even the plane of our own Milky Way. To achieve this, the project employs some of the world's most powerful radio telescopes, including the Green Bank Telescope in West Virginia, the Parkes Observatory in Australia, and the Meerkat Array in South Africa. These instruments are capable of detecting even the faintest signals, making them ideal tools for this cosmic search. But what sets Breakthrough Listen apart is not just its scale, it's also its methods. The initiative uses cutting-edge technology to analyze the data it collects, employing advanced algorithms and machine learning to sift through the noise of the cosmos. This allows scientists to identify potential signals that might otherwise go unnoticed. For example, Breakthrough Listen has developed software that can distinguish between natural phenomena like pulsars or fast radio bursts and signals that could potentially be artificial in origin. This level of precision is crucial in the search for extraterrestrial intelligence, where even the smallest anomaly could hold the key to a monumental discovery. So far, the initiative has identified several intriguing signals that have sparked excitement among scientists and enthusiasts alike. One of the most notable was a narrowband signal detected from Proxima Centauri, the closest star system to Earth. While the signal, known as BLC-1, was eventually attributed to human-made interference, its initial detection highlighted the potential for finding something extraordinary. Other signals, like those from fast radio bursts and unusual stellar activity, continue to be analyzed, keeping the possibility of alien contact alive. What makes Breakthrough Listen truly remarkable is its commitment to transparency and public engagement. All the data collected by the initiative is made freely available to the public, allowing anyone with an interest in the search for extraterrestrial intelligence to explore the findings. This open approach not only fosters collaboration, but also invites the world to share in the excitement of discovery. As we look to the future, Breakthrough Listen stands as a testament to humanity's enduring curiosity and determination to explore the unknown. With its state-of-the-art technology, ambitious goals, and collaborative spirit, this initiative is pushing the boundaries of what we know and what we might one day discover. Whether or not it finds definitive proof of alien life, Breakthrough Listen is already reshaping our understanding of the cosmos and inspiring a new generation to look to the stars with wonder and hope. Now, let's shift our focus to one of the most thought-provoking questions in the search for extraterrestrial intelligence, the Fermi paradox. Named after physicist Enrico Fermi, this paradox highlights a puzzling contradiction. Given the vastness of the universe and the high probability of life-sustaining planets, why haven't we found any definitive evidence of alien civilizations? It's a question that has puzzled scientists and philosophers for decades, and it has profound implications for our search for mysterious messages from deep space. At its core, the Fermi paradox asks, where is everyone? With billions of stars in our galaxy alone, many of which host Earth-like planets, it seems statistically likely that intelligent life should exist elsewhere. Yet, despite decades of searching, we've found no clear signs of extraterrestrial communication. This absence of evidence raises several intriguing possibilities. One explanation is that intelligent civilizations are incredibly rare, either because the conditions for life are far more specific than we realize, or because advanced societies tend to self-destruct before they can make contact. Another possibility is that alien civilizations exist but are so advanced that their methods of communication are beyond our current understanding or detection capabilities. The Fermi paradox also invites us to consider the limitations of our own technology. While projects like Breakthrough Listen have made incredible strides in scanning the cosmos, our ability to detect alien signals is still in its infancy. We might be missing subtle signs of communication simply because we don't yet have the tools to recognize them. For example, alien civilizations might use forms of communication that don't rely on radio waves, such as laser signals or quantum entanglement, which we're only beginning to explore. Alternatively, they might intentionally avoid contact with less advanced species like us, adhering to a kind of cosmic prime directive. Another fascinating angle is the idea that we might be looking in the wrong places or at the wrong times. The universe is unimaginably vast, and even a single galaxy like the Milky Way spans hundreds of thousands of light years. Signals from distant civilizations could take thousands or even millions of years to reach us, and by the time they do, the civilization that sent them might no longer exist. Similarly, our own signals have only been traveling through space for about a century, covering just a tiny fraction of the galaxy. It's entirely possible that alien messages are out there, but we simply haven't been listening long enough or in the right way to detect them. Despite these challenges, the Fermi paradox doesn't diminish the importance of the search for alien messages. In fact, it underscores the need for continued exploration and innovation. Every mysterious signal we detect, whether it's a fast radio burst or an unexplained radio emission, brings us one step closer to answering the question of whether we're alone in the universe. And while we may not have found definitive proof yet, the very act of searching expands our understanding of the cosmos and our place within it. As we ponder the Fermi paradox, it's worth remembering that the absence of evidence isn't evidence of absence. The universe is full of mysteries waiting to be uncovered, and the search for alien messages is far from over. With each new discovery, we edge closer to solving one of humanity's greatest enigmas, and perhaps one day we'll finally find the answer to Fermi's haunting question. Until then, the journey itself is a testament to our curiosity, ingenuity, and unyielding desire to explore the unknown. Now, let's turn our attention to a powerful tool that has shaped our understanding of the search for extraterrestrial intelligence, the Drake equation. Developed by astronomer Frank Drake in 1961, this equation isn't just a mathematical formula. It's a framework that helps us estimate the likelihood of detecting alien messages. By breaking down the vast unknowns of the cosmos into manageable factors, the Drake equation gives us a way to think about the probability of intelligent life existing elsewhere in the universe. At its heart, the Drake equation considers 7 key variables. These include the rate at which stars form in our galaxy, the fraction of those stars with planetary systems, and the number of planets within those systems that could support life. It also factors in the likelihood of life developing on those planets, the probability of that life evolving into intelligent civilizations, and the chances that such civilizations would develop the technology to communicate across interstellar distances. Finally, it considers the length of time these civilizations might transmit detectable signals into space. While some of these factors are based on scientific data, others remain speculative, which is why the Drake equation is as much a conversation starter as it is a calculation. One of the most intriguing aspects of the Drake equation is how it highlights the challenges of signal detection. Even if intelligent civilizations are out there, finding their messages is no simple task. For one, the vast distances between stars mean that signals could take thousands or even millions of years to reach us. By the time they do, the civilization that sent them might no longer exist. Additionally, alien civilizations might use forms of communication we haven't yet discovered or don't fully understand. Radio waves, which we currently rely on for SETI efforts, might be just one of many possible methods of interstellar communication. Another challenge lies in interpreting the signals we do detect. Not every unusual signal is a sign of extraterrestrial intelligence. Natural phenomena such as pulsars or fast radio bursts can produce signals that mimic artificial ones. Even human-made interference like satellite transmissions or radar signals can muddy the waters. This is why scientists must carefully analyze each potential signal, ruling out natural and human-made sources before considering the possibility of an alien origin. Despite these challenges, the Drake equation reminds us that the search for alien messages is far from hopeless. Each new discovery in astronomy, whether it's the detection of an Earth-like exoplanet or the identification of a potentially habitable environment, brings us closer to refining the equation's variables. And as our technology advances, so too does our ability to detect and interpret signals from distant stars. Projects like Breakthrough Listen and the SETI Institute are pushing the boundaries of what's possible, scanning the skies with ever greater precision and sensitivity. The Drake equation also invites us to think about the broader implications of our search. If we were to detect a signal from an alien civilization, it would fundamentally change our understanding of our place in the universe. It would answer one of humanity's oldest questions, are we alone, while raising countless new ones. What would such a discovery mean for science, philosophy, and even our sense of identity as a species? These are questions that the Drake equation doesn't answer, but it certainly inspires us to ask. As we continue to explore the cosmos, the Drake equation serves as both a guide and a reminder. It reminds us that the search for alien messages is as much about the journey as it is about the destination. Every signal we detect, every planet we discover, and every question we ask brings us closer to understanding the universe, and perhaps one day to finding the answer we've been searching for. Now, let's shift our focus to a groundbreaking development that's revolutionizing the search for extraterrestrial intelligence: the role of artificial intelligence in signal analysis. As the amount of data collected from the cosmos grows exponentially, traditional methods of analysis are struggling to keep up. This is where artificial intelligence steps in, offering a powerful tool to sift through the noise and uncover potential alien messages hidden in the vast sea of cosmic signals. Artificial intelligence excels at processing massive datasets quickly and efficiently. In the context of SETI, AI algorithms are trained to identify patterns and anomalies in radio signals that might indicate an artificial origin. Unlike human analysts who can only review a fraction of the data, AI systems can analyze millions of signals in real time, flagging those that stand out as unusual or potentially significant. This capability is transforming the way scientists approach the search for extraterrestrial intelligence, making it faster, more accurate, and more comprehensive. One of the most exciting applications of AI in this field is its ability to detect subtle patterns that might otherwise go unnoticed. For example, AI can identify signals that exhibit characteristics of deliberate modulation or encoding, features that could suggest an intelligent source. It can also distinguish between natural phenomena like pulsars or fast radio bursts and signals that might have an artificial origin. By filtering out the background noise of the universe, AI helps researchers focus on the most promising candidates for further investigation. Another advantage of artificial intelligence is its adaptability. As new types of signals are discovered or new theories about extraterrestrial communication emerge, AI systems can be retrained to look for different patterns or signatures. This flexibility is crucial in a field where our understanding of the universe is constantly evolving. AI also plays a key role in managing the sheer volume of data generated by modern telescopes and observatories. Without it, the task of analyzing every signal would be overwhelming, if not impossible. However, the use of AI in signal analysis is not without its challenges. One concern is the risk of false positive signals that appear artificial but are actually natural or human-made. To address this, scientists use a combination of AI and human expertise to verify potential detections. AI narrows down the possibilities, while human analysts apply their knowledge and intuition to assess the likelihood of an extraterrestrial origin. This collaborative approach ensures that the search remains rigorous and scientifically sound. The integration of artificial intelligence into SETI efforts is still in its early stages, but the potential is immense. Projects like Breakthrough Listen are already leveraging AI to scan the skies with unprecedented precision, and the results are promising. As AI technology continues to advance, it could unlock new possibilities for detecting and interpreting signals from distant civilizations. This fusion of cutting-edge technology and cosmic exploration brings us closer than ever to answering one of humanity's most profound questions: are we alone in the universe? As we look to the future, the role of artificial intelligence in signal analysis will only grow. It represents a new frontier in the search for extraterrestrial intelligence, one that combines the power of technology with the curiosity and ingenuity of the human spirit. With AI as our ally, the hunt for alien messages is entering an exciting new chapter, one that could bring us closer to a discovery that changes everything. Now, let's turn our attention to a question that goes beyond the technical challenges of detecting alien signals. What are the ethical implications of contacting extraterrestrial civilizations? The idea of reaching out to or receiving messages from alien intelligence raises profound moral and philosophical questions that humanity must carefully consider. While the prospect of contact is thrilling, it also comes with risks and responsibilities that could shape the future of our species. One of the primary ethical concerns is the potential danger of making contact. If an alien civilization is technologically advanced enough to send or receive interstellar messages, they might also possess capabilities far beyond our own. This raises the question, could reaching out expose humanity to unforeseen threats? Some scientists and thinkers argue that broadcasting our presence into the cosmos could be risky, as we have no way of knowing the intentions of an alien species. It's possible that a civilization with superior technology might view us as a resource to exploit or a threat to eliminate. This concern has led to debates about whether we should continue sending messages like the Arecibo message or remain silent to avoid drawing attention to ourselves. On the other hand, there are compelling arguments in favor of making contact. Proponents of active SETI, the deliberate transmission of messages to potential extraterrestrial civilizations, believe that the benefits could outweigh the risks. Contact with an advanced alien species might provide humanity with access to knowledge and technology that could solve some of our greatest challenges, from climate change to disease. It could also offer a new perspective on our place in the universe, fostering a sense of unity and shared purpose among people on Earth. The potential for cultural and scientific exchange is immense, and some argue that the pursuit of such opportunities is worth the inherent risk. Another ethical consideration is the responsibility we have as a species to represent humanity in a way that reflects our best qualities. If we do make contact, what message should we send? Should we focus on sharing scientific knowledge, or should we also include aspects of our culture, art, and philosophy? Crafting a message that accurately represents humanity is no small task, and it raises questions about who gets to decide what we say and how we say it. This responsibility underscores the need for international collaboration and careful deliberation to ensure that any message we send is thoughtful, inclusive, and reflective of our collective values. There's also the question of how we should respond if we receive a message from an alien civilization. Deciphering and interpreting such a message would be a monumental challenge, but it would also come with ethical dilemmas. Should we reply immediately, or should we take time to carefully consider the implications? Who would have the authority to make such a decision on behalf of humanity? These questions highlight the need for global cooperation and the establishment of protocols to guide our actions in the event of contact. The ethical considerations of contacting aliens extend beyond the immediate risks and benefits. They touch on deeper questions about our role in the universe and our responsibility as a species. Are we ready to take on the challenges and opportunities that contact might bring? How do we balance our curiosity and desire for exploration with the need to protect ourselves and our planet? These are questions that don't have easy answers, but they are essential to consider as we continue our search for extraterrestrial intelligence. As we navigate these complex ethical waters, one thing is clear: the decision to contact or respond to an alien civilization is not one to be taken lightly. It requires careful thought, international collaboration, and a deep understanding of the potential consequences. Whether we choose to reach out or remain silent, the choices we make today could have far-reaching implications for the future of humanity. And as we ponder these questions, we are reminded that the search for extraterrestrial intelligence is not just a scientific endeavor. It's a deeply human one, shaped by our hopes, fears, and dreams of what lies beyond the stars. As we move forward, the future of the search for extraterrestrial intelligence holds incredible promise, driven by advancements in technology and innovative missions that could redefine our understanding of the cosmos. One of the most exciting developments is the rise of next-generation telescopes, such as the James Webb Space Telescope and the upcoming Extremely Large Telescope. These instruments will allow us to peer deeper into space than ever before, analyzing the atmospheres of distant exoplanets for signs of life. By studying the chemical composition of these atmospheres, scientists hope to detect biosignatures, indicators that could point to the presence of living organisms. Another groundbreaking initiative is the Breakthrough Listen project, which continues to scan the skies for potential alien signals. With access to some of the world's most powerful radio telescopes, this project is expanding its search to include millions of stars and galaxies. Breakthrough Listen is also leveraging artificial intelligence to sift through vast amounts of data, identifying patterns that might indicate intelligent communication. This combination of cutting-edge technology and advanced algorithms is transforming the way we search for extraterrestrial messages, making the process faster and more efficient than ever before. In addition to these efforts, new missions are being planned to explore our own solar system for signs of life. For example, NASA's Europa Clipper mission aims to study Jupiter's moon Europa, which is believed to have a subsurface ocean that could harbor life. Similarly, the Dragonfly mission will send a drone-like spacecraft to Titan, Saturn's largest moon, to investigate its unique chemistry and potential for life. These missions remind us that the search for extraterrestrial intelligence isn't limited to distant stars. It could also lead to discoveries much closer to home. The future of SETI also includes collaborative efforts on a global scale. Initiatives like the Square Kilometre Array, a massive radio telescope project involving multiple countries, will provide unprecedented sensitivity and resolution. This international collaboration highlights the shared curiosity and determination of humanity to answer one of our most profound questions: are we alone in the universe? By pooling resources and expertise, scientists are building tools that could finally bring us closer to finding an answer. As we look ahead, it's clear that the search for extraterrestrial intelligence is entering a new era of discovery. With advanced technologies, ambitious missions, and global cooperation, we are better equipped than ever to uncover the mysteries of the cosmos. The journey ahead is filled with challenges, but also with the potential for groundbreaking revelations that could change our understanding of life itself. And as we continue to explore, we are reminded that the search for alien messages is not just a scientific quest. It's a testament to humanity's enduring curiosity and our desire to connect with the unknown. Now, let's turn our attention to the most promising signals being investigated today, signals that could hold the key to answering humanity's most profound question. Among these, one of the most intriguing is the BLC-1 signal, detected in 2020 by the Breakthrough Listen project. This signal, originating from the direction of Proxima Centauri, stood out due to its narrow bandwidth and apparent lack of natural explanation. While further analysis suggested it was likely interference from human technology, its initial detection sparked excitement and highlighted the challenges of distinguishing between artificial and natural signals. The BLC-1 case serves as a reminder of how careful scientists must be in their search for extraterrestrial intelligence, as even the most promising candidates can turn out to be false alarms. Another signal generating significant interest is the repeating fast radio burst known as FRB-121102. Unlike most fast radio bursts, which are one-time events, this signal has been observed repeating multiple times, making it a prime candidate for further study. Its source, located in a dwarf galaxy billions of light-years away, remains a mystery. Some scientists speculate that it could be caused by highly energetic cosmic phenomena, such as neutron stars or black holes, while others entertain the possibility of advanced alien technology. The repeating nature of FRB-121102 makes it a unique and compelling target for ongoing research, as it offers scientists the rare opportunity to study a signal over time. Closer to home, the signal detected from Proxima Centauri in 2019 continues to captivate researchers. This signal, which appeared to originate from the star's habitable zone, was initially thought to be a potential sign of extraterrestrial communication. However, like the BLC-1 signal, it was later attributed to human-made interference. Despite this, the detection reignited interest in Proxima Centauri, a star system that hosts Proxima b, a potentially habitable exoplanet. The proximity of this system to Earth, just over 4 light-years away, makes it a prime candidate for future exploration and the search for extraterrestrial life. Finally, the mysterious dimming patterns observed around Tabby's star, or KIC 8462852, remain a subject of intense scrutiny. While the most widely accepted explanation involves dust clouds or other natural phenomena, the possibility of an alien megastructure, such as a Dyson sphere, continues to capture the imagination of both scientists and the public. Ongoing observations aim to uncover the true cause of these irregular dimming events, which could either confirm a natural explanation or open the door to one of the most extraordinary discoveries in human history. These signals, each with their own unique characteristics and mysteries, represent the cutting edge of the search for extraterrestrial intelligence. While many have been explained as natural phenomena or human interference, their initial detection underscores the importance of continued vigilance and innovation in this field. As technology advances and our methods of detection improve, the likelihood of identifying a genuine extraterrestrial signal grows ever stronger. The search is far from over, and each new discovery brings us one step closer to answering the ultimate question: are we alone in the universe? As we bring our journey through these 25 mysterious messages from deep space to a close, it's clear that each signal, each anomaly, and each unexplained phenomenon represents a piece of a much larger puzzle. From the iconic wow signal to the enigmatic repeating fast radio bursts, and from the tantalizing possibilities of alien megastructures to the challenges of distinguishing human interference from potential extraterrestrial communication, these discoveries remind us of the vastness and mystery of the cosmos. They challenge us to keep looking, keep questioning, and keep pushing the boundaries of what we know. The search for extraterrestrial intelligence is far from over. In fact, it's only just beginning. With advancements in technology, the launch of new telescopes, and the growing collaboration between scientists and citizen scientists, the chances of detecting a genuine alien message grow stronger every day. But even if we haven't found definitive proof yet, the journey itself is invaluable. It teaches us about the universe, about ourselves, and about the incredible potential for discovery that lies ahead. So, what do you think? Could one of these signals be the key to unlocking the greatest mystery of all? Whether we're alone in the universe, or will the next breakthrough come from a signal we haven't even detected yet? The answers are out there, waiting to be found. And as we continue to explore, we invite you to stay curious, stay engaged, and keep looking up at the stars. If you enjoyed this deep dive into the mysteries of deep space, don't forget to like this video, subscribe to our channel, and hit the notification bell so you never miss an update. And let us know in the comments which of these mysterious messages fascinates you the most. What do you think we'll discover next? The universe is full of secrets, and together we can uncover them. Thanks for watching, and until next time, keep exploring.